Okay, sagebrush steppe rangelands are increasingly threatened by the spread of exotic annual grasses and wildfire. And this project addresses the information needs needed to address the problem for success in restoring these areas. It's important to keep in mind that these burned areas oftentimes are hundreds of thousands of acres in size. And there can be a lot of uncertainty on the condition of the vegetation both before and in the years after fire. Most of the people on this call will have a deep appreciation for how variable the landscape can be and how this translates into variable vegetation recovery. I mean, in addition to topographic variability in soils, we also have patches of exotic plants trying to work their way back in the landscape. From the last presentation, we gain an appreciation of how patchy grazing can be, and that's really critical for the recovery of these burned areas. And then in time, weather variability is a major source of uncertainty. And I'd like everybody to keep in mind or appreciate that, you know, the tools and the measurement rubrics that we have been using in restoration have been affected by, or influenced by agricultural sciences. I mean, a lot of the tools used for restoration were actually borrowed from agriculture. And we're still moving out of this domain of thinking of these landscapes as being homogeneous and thinking about how we can deal with variability and uncertainty. And these are real opportunities. You know, if we can address these effectively, there are opportunities to make restoration work better in these landscapes. So scroll forward, 2015 Soda wildfire on the Idaho-Oregon state border. This became a national test bed of high-level investment of post-fire restoration treatments and monitoring that was commensurate with the effort. All done, partly motivated by sage grouse conservation. So for 5 years, these treatments went on, and the monitoring done for it was delegated to us in the USGS. Now, the key thing is, as we've heard, most monitoring addresses a few points measured repeatedly over time to detect temporal trend. But in the case of a large burned area, you need to measure lots of points over large landscapes in a very short amount of time. And if you can do that, then the information needed to, number one, to tell the land managers about where retreatment needs and opportunities exist will be enabled. Second, you'll have much better reporting for accountability on all of the investments made into restoration. And then third, we can do a much better job of informing land managers on critical things like when is the landscape ready to withstand the grazing pressures that come with livestock grazing. So this map here shows you that there's over 100 different pasture and allotment boundaries of management units. Superimposed on top of this in the Soda burned area was tens of thousands of acres each for herbicide treatments, seedings of perennial grasses, 180,000 acres of sagebrush seedings. And all of these intersections, all of these unions of different polygons needed to have enough sampling on them in order to enable us to go beyond just simply looking at the mean value of vegetation responses, and instead to think about the variability in them. And for this, it was determined by the land managers to focus on 80% confidence intervals. And we used a proper sampling power procedure to determine how many points needed to be measured. All those little black points are monitoring plots, over 2,000 of them. And here's some quantitative objectives that were used. There was a lot of uncertainty as to whether or not these were the right objectives. Here for bunch grasses, people wanted to see that the bunch grasses had at least 20% cover in order to determine that the objectives have been met. In contrast for sagebrush, kind of exciting. Here, sagebrush, we appreciated that it doesn't come back homogeneously across the landscape. Instead, we might expect to make our metrics based on where sagebrush, how abundant is sagebrush in microsites deemed to be suitable for it. Well, then that begs the question of what is a suitable microsite? Well, the monitoring data helped us learn that. We couldn't use standard LPI techniques, line point intercept. They're too time intensive. We used this photo I borrowed from David here shows somebody taking an aerial photograph. We used sample point. This was really good because it allowed everybody to go back to see the actual data firsthand. So the BLM range conservationists and the ranchers were able to, the livestock permittees were able to actually look at the data if they were struggling with the quantitative data that we were delivering to them. And the effect of this is that it generated a lot of trust. This was critical. The monitoring was delegated to the USGS. So there's this three-way trust pattern between the BLM, the livestock operators, and USGS. These concentric rings show an efficient way for us to search larger and larger areas for density of key species. We tweaked our methods for each individual parameter. None of these are very well measured by remote sensing. So, I mean, I hate to say it, but field monitoring will never go away. We were able to sneak in some new terms like measuring soil surface properties, and all of these led to tremendous insights, magnificent, exciting insights in my perspective on restoration. And so, for example, we found that sagebrush, you know, obviously it doesn't come back up like corn does after seeding. It's very patchy, and that patchiness contains lots of key information about the soils, elevation, lots of factors. You're able to make these decision support trees to help figure out where are you more likely to see sagebrush recovery. You can use that for planning treatments, and you can use that for assessment. So let me recap. We need ways of measuring large areas quickly, and so we can embrace that variability. Building trust is key with transparent, reproducible, and reviewable monitoring. And in this case, delegating the monitoring to the USGS was handy because we were able to maintain our focus. The investment into the restoration could not be redirected towards other agency needs. And I think that caused the soda fire monitoring, which I want to say there were some people that thought that it wasn't possible, what we were trying to accomplish. 2,000 points over 300,000 acres, monitoring those every year for 5 years. Well, we accomplished it despite the odds. And I do think that the delegation of this to a third party, in this case, helped. So interagency cooperation is key. Thank you.